Hey all you crazy cats and kittens! In this video we will be discussing section 12.5 and continuing on with volumes of cones. This is page 829 of your textbook. Alright, so previously we had talked about how the volume of a prism is the area of your base times your height, and then when we take that prism, those same measurements, and make it into a pyramid instead, we have this 1/3 piece that we have to include here. So that's going to be the exact same thing here for a volume of a cone. However, we actually do know the shape of our base, so we can find the area of the base using a more specific formula, pi r squared. The shape of the base of your cone is always a circle, so the area is always going to be pi r squared. Alright, one additional note here is when I type this into my calculator, pi r squared h, I always divide it by 3 instead of having that 1/3 piece at the beginning. I just find that that's easier, and that's a little calculator hack, I guess, for you. So here in example 1, they ask us to find the volume of the solid. Now, yes, this is not a right cone. Alright, that means it's not straight up and down. The vertex is not over the center of your base here. However, I can still use the formula. I know radius and I know the height of my cone. So, I identify the general formula. I can get more specific here since I know the shape of my base. I substitute in my values, my radius and my height. 2.2 for my radius, 4.5 for my height. And then I go ahead and calculate it out with that 1/3 piece. I did want to remind you that I divide by 3 instead of doing the 1/3 at the beginning. This boxed answer is your exact answer. Alright, so if I were asking you for an exact volume, that's what you would give me with centimeters cubed here. But if you were to approximate, it's about 22.81 centimeters cubed, or cubic centimeters. Alright, so here's a guided practice for you. You need to identify your radius first and your height first. So you might have already caught it. This is not your height. Alright, 8 is not your height. 8 is your slant height. So how can you possibly find your height when you have your radius and your slant height? You use the Pythagorean theorem. So my actual height is going to equal the square root of 8 squared minus 5 squared. Alright, and you're going to approximate that. So pause the video and then see if you can find the volume. Alright, so it should have come out to about 163.49 meters cubed. Alright, guided practice 3, pause it. Hopefully you got the height around 12.5 meters. So make sure you know what they're actually asking for. They're not asking for volume. They're asking for a height here. So it should be answered in meters, not meters cubed. And this is just constructing the problem a little bit differently. You're just filling in for different variables. So you will have to divide in this example. Alright, example 3 here. Find the volume of the right cone. Now, as you can see from the picture, they don't give us R, but they do give us the height of 16 feet, and then they give us an angle. So one of the things that we're going to do is we're going to pull out this triangle. It is a right triangle, so that's one of the things that's going to help us. Alright, so if I were to find the radius R, there's a couple of things that I can do. Alright, I need to identify, according to this angle, which sides I have. I can use my trig functions. So I'm going to write out SO, CA, TOA. It only takes a couple of seconds. And I'm going to identify which sides I have labeled. So according to this angle, I have the side opposite, and then I have the side adjacent. I do not have the hypotenuse. Alright, so that means I'm going to be setting up the tangent function. So the tangent of 65 degrees equals 16 over r. and then I solve from r for there by cross multiplying and dividing, and I get r approximately equals, working through that, so this is what it's going to be like when you type it into your calculator, and I get r to equal approximately 7.46. Alright, we are not finished with the problem. That just gave us the radius. So then into my final formula, I plug in my approximated, it is approximated here, radius, and my height, and I get about 932.45 feet cubed, or cubic feet. Alright, so going forward to example 5, you are using the funnel shown to measure the coarseness of a particular sand. Okay, cool, good for you. It takes 2.8 seconds. Alright, so they give us time here. I'll probably have to use that to empty out the funnel. Find the flow rate. So the flow rate is going to be in milliliters per second. So I am going to have to find my cubic centimeters. I'm going to have to find my volume, and then just change that into milliliters and divide it by the time. Alright, so I have the given radius of 4 and height of 6. So first, write out your formula. Always write out your formula. Step 2, substitute in your values. 3, tippity type it into your calculator and convert those cubic centimeters into milliliters. Okay, so now I have the volume, and then I need to take the volume and divide it by our time here to actually find the flow rate. Alright, so my rate, units on my rate should be divided, milliliters per second, and there is my flow rate. So the flow rate is about 36.07 milliliters per second. So here's a couple of guided practice for you. Find the volume of the right cone. Alright, so it might be a different trig function or a similar setup. So set up a trig function to find your radius, and then find the volume. So pause the video, see if you can get there. Alright, of course, if you guys have any questions, please feel free to shout out and send me an email. I look forward to hearing from you.